process to take carbon out of the atmosphere. First, efficiency, right? If you can do the same at higher efficiency, you do what? You generate less emissions. Yeah. If you get a car that they can do 50 miles to the gallon versus 15, you save the environment a lot of CO2, right? Same if you increase the power plant performance or the chemical plant. Okay, you can do some of that. Building new facilities, you can build them with the most modern technologies which achieve really higher efficiency, and on and on and on and on. And somewhere up there you will see carbon capture and storage. So all this is an arsenal of technologies. Some of them a bit easier to apply, some of them need more time and a little bit more difficult. But the whole idea is that step-by-step process going from one to another, then that would lead you to decarbonizing the economy. And nobody will argue with efficiency, nobody will argue with conservation. I go to hotel's room and the first thing I do is I freeze to death. I don't know why they're compelled to put the air conditioning full speed, even in the wintertime. So we're very inefficient, right? Other countries are much better. For example, if you've ever been to Europe, you know you open your door to go to your hotel room, and unless you put that key into a hole, there is no power, right? You have to actually power the room by putting your key in there. You have seen it, there is a little slot. And I was in a hotel in Italy one time, and my next door neighbor was moaning and groaning that he couldn't work his air conditioning. And I said, what do you mean, mine works? And I went over there. What he did was he had this nice sea view in Naples. He opened his veranda door to see it, and he realized as soon as he opened the door, guess what? The power turned off, right? So people are building small things, but all the time. If you go to most countries in Europe, you will see every house mandatory has a solar water heater, right? These are small things everybody can do. It's not a big deal, but there is so much carbon out there. If you're talking about really doing something, you need to talk about carbon capture and storage. Let's talk also about emission and trends. Now, this is here the latest from the Redrawing the Energy Climate Map, which is the World Energy Outlook that is done out of the International Energy Agency, which is in Paris. What it shows the difference in 1 year between 2011 and 2012 in CO2 emissions. The only country who really has made some significant difference is the US. Europe a little bit. Everybody else is moving more and more from year to year. Most of these countries have signed the Kyoto Protocol. They don't seem to be doing pretty good by signing an agreement that will do much better. We didn't sign any protocol and we're doing much better than anybody else. There is reasons for it. Some of it actually they're accidental. The economy went down, industrial output went down, less energy, less electricity, right? But we have done conservation, we have done a little bit of efficiency, and of course we're using more gas than we used to. Put it all together, there is some path to say, well, that is a significant reduction over a period of 1 year, best at what everybody else is doing. If you go to this diagram, also by the same agency, it tells you the difference between 2010 and 2017 as predicted. If you look at the circles here, this is a significant smaller circle. If you look at China, they're going the other way, okay? So if you look at Europe, is minimal any difference at all. So you could say that in the US, the way we're moving, we are making some significant steps towards reducing CO2 here, and the steps are there blatant and obvious. Let's move now to climate change. Climate change debate started with the first report of the United Nations Intergovernmental Panel for Climate Change. Now, in 2013, they produced their second report. Now, the second report was quite a bit different than the first. The conclusion was the same, that would be all doom and gloom and what have you. But now what they're saying is this: when they did all their computer modeling between 1992 to 2005, they came to the conclusion that the rate of change of temperature would be 0.2 degrees centigrade per decade. That's quite a significant kind of number. Now they went back and recalibrated from another day to another day. They took 15 years all the way to the year 2012. And what that says is that that change in temperature is 0.05 degrees. In essence, basically, all their models, and they used 90 of them, they were grossly wrong in calculating what that difference in temperature would be. And if you all have seen the winter we've been having this year, I don't think anybody will claim we'll have any kind of global warming. Now, I don't question climate change, I question the issue of global warming. So what happened? Many of the scientists who were part of this report got pretty fed up. And the most important statement came out of a senior member of that committee, who is a professor at Oxford University, who said this should be the last IPCC assessment, and accused basically that entire panel of doing nothing else but misrepresenting how science works. That's a pretty strong statement for somebody who is within the panel. There is actually 3 other people, including the Georgia Tech professor and climatologist, who are saying the same thing. So I'm not trying to get into a debate about climate change, but what I'm saying is, what we know so far, we are reducing CO2. What we know else, that there is some questions about the whole climate change and global warming, right? So it was not, let's say, a surprise, but nevertheless a shock when EPA came with a proposed ruling at a time that the country appeared to be on its way to do something without needing any specific additional regulations, right? And basically most people believe if you let things be, and if you enhance these technologies, you will get where you want to be without needing any shock type of regulation. However, EPA had a different opinion and provided for the first time a rule back in September. This was a proposed rule, then they changed to a more formal rule. There was not any much change in the numbers really to be of a great deal of significance, but basically the rule says very, very briefly that when you construct new power plants, you have a limit as to how much CO2 these power plants should emit. And the limit was roughly about 1,000 pounds of CO2 per megawatt hour. Now, some of you may not be into technical sort of lingos and all that kind of stuff, but just to put it in some reality comparison, a typical very efficient coal plant does over 2,000, and there is really not any technology to get it from 2,000 to 1. Actually, it's over 2,000, right? And a gas plant does about 800. So they are within the limit. That's how some people call this regulation the gas supporting regulation or what have you. So in essence then, that was a proposed rule, and there were some issues that I'm sure the lawyers amongst you, and I'm sure there are many, will be interested in. The EPA administrator said, this is not a rule to kill coal. That's not our intention, because, she said, coal has an opportunity to stay within this rule by using carbon capture and storage. And she said further that this particular technology is currently feasible and available. And I understand that if EPA provides some technology as a means of a solution, really cannot legally do that unless that technology is available and proven. Available, I would mean, you guys should know more about than I do, but it would mean there's at least 2 or 3 vendors that can supply it and not one. And feasible, of course, financially and economic and technologically speaking, it makes sense. So that was EPA's point of view. EPA said, we're not against coal, we're not doing anything, we're going to clean up the environment, we provided the rule, and the coal plants can live with it. The only thing they have to do, carbon capture and storage, and that technology is proven and it is available. So, in order to demonstrate the point of proven and available, EPA lists 4 projects, 4 power plants, who have some form of carbon capture and storage installed. Now, before I show you something about these power plants, I must tell you some common threads about all of them. None of them is operating. None of them is completed yet. And some of them haven't even started being built. All of them have enjoyed huge amount of government funding. It's not a typical utility kind of a power plant. I'm talking about $250 to $400 million for putting this plant together. And all of them, they are actually selling the CO2, the captured CO2, for what is known as enhanced oil recovery. We'll talk about this in a minute. So these are the power plants that I have circled. These are basically the larger plants that we have out there trying to do something different. These are the 3 in this country, and the 4th one was in Canada. So let's talk a little bit about this plant. The first one was a plant that the Southern Company is doing in Mississippi, in Kemper County. So it's known now all over the world as the Kemper County Power Plant. And that power plant is under construction. That power plant is a unique method to generate electricity using what is known as IGCC technology, integrated gasification combustion cycle, which is a very expensive technology. And that particular power plant will actually capture the CO2, and currently all that CO2 has been sold to people who need the CO2 to do enhanced oil recovery. The next plant, which is the Boundary Dam in Canada, is under construction. I should mention also that the Kemper County facility, who was at 2.6 billion, now is close to 5 billion. Okay, so there is all sorts of issues about the cost overruns. Then there was the Texas Clean Energy Project, which actually is on the planning stage, right? It's not even been built yet. That's supposed to be in the Permian Basin, which is in Texas, and therefore close to the enhanced oil recovery, which again, I will talk a little bit also. And then there is a California project, which is actually petcoke projects to hydrogen. Also the CO2 will go for enhanced recovery, and that actually is on the drawing board. So you don't need to be a very critical scientist to say, how can you say if something is proven and available if none of them has ever operated yet, right? So EPA now says this, and DOE says this. You know what? These are the first generation plants. And this technique cannot be used anywhere else because economically it's totally unreasonable. Now, to give you an example, the cost to do the capture here will more than double your electricity. In other words, for every ton of CO2 they're trying to get rid of doing these technologies, it's costing them $70 to $80 a ton, and they emit about 5 million tons per year. So they admit that this technology is not really the technology that will be deployed, right? But what they are saying, and there is some reason to this, every time there is something new, the first one you build is what? Is inefficient, it has bugs, look from software to any type of machine. By the time you come to build a tenth of that, you are much better. So they said, we are saying this proven and available because some company decided to do it, and they weren't worried about the safety, and they weren't worried how it will integrate with the facility, even if they were losing a hell of a lot of money, or they're forcing the ratepayers to pay 2 or 3 times the price. That basically is the rationale here. Actually, the Southern company who has the Kemper facility warned everybody not to take their project as a typical project. Now, why is that? This is a unique facility. The power plant is here, and beside the power plant in Mississippi is a huge surface lignite mine. So the lignite, which is a cheap quality of coal, drops directly from the mine into the power plant. So there's a lot of savings. And then right in front of the plant there is a pipeline who takes CO2 from Mississippi and takes it to Texas for enhanced oil recovery in the Texas field. So the only thing they have to do with CO2 is just put it on the power plant, right? We don't have any pipelines around here, as you all know. So if we capture the CO2, how are we going to get it to Texas, right? We cannot track it down there, so what are you going to do with it? So that is a specific case, a specific example, already in significant cost overruns, and that's why the Southern company said, don't really use this project as something that is the norm in a way. Now, the CO2 rule has a significant impact on coal power generation because it's forcing a lot of utilities to do a number of things. They are not really going to build new coal-fired power plants because they don't believe that carbon capture and storage technologies are ready and available and economic, and they have to deal with the ratepayers where they're going to get permission to charge 80% more. Also, they have other alternatives right now with gas, but they don't have to face that. So according to the experts, there will be a significant retirement of existing plants and of new plants that will never materialize because of that rule. Now, what that would mean is anybody guess. DOE says 70 gigawatts of power will be lost. That is a significant amount. Actually, the industry and others and the utilities and EPRI, which is the utility sort of group, and Edison Electric talk about 120 gigawatts. In other words, 1/3 of all coal-fired generation will disappear. And that's what that means. Now, we still don't have the rules of EPA for existing power plants. This covered new power plants, right? And it appears that they said that rule will be out April or May. Now they said June or July, but it's a question of months when it comes with the rule here. And what is interesting actually is a Bloomberg article recently, a couple of days back. And Bloomberg is not really the best friend of the coal business. He's a fanatic supporter of other energy sources rather than coal. But it was interesting because what he's saying is the polar vortex is bringing few things in mind, amongst which that you need reliable, cheaper energy in order to get over the winter months. And what is important is what Senator Murkowski said, who is basically the minority chair in the Energy Committee at the Senate. And what basically that says is during the cold months, 89%, 90% say, of all these power plants that were slated to disappear because of environmental rules, they had to work full time to keep the heating going in the rest of the country. And as you may know, you might have read also that even the gas pipelines couldn't deliver the gas necessary for the gas power plants in North England. So before we dismantle 1/3 of the power generation, we need to think very carefully about how we do it and what will be the implications in cost, the implications in availability, and implications on everything. We have one significant unique winter weather and we cannot even handle that with the help of these older plants. So, carbon capture and storage then is a vital component of let's say, reducing and managing carbon. And if you go to any major agency, whether it is the International Agency or DOE, you will see all these wedges or triangles that says, if we were down here in CO2 and in year 2050 we want to be here and less, if we do nothing, we're going to go this way. If we do carbon capture and storage, we're going to drop that much. If we do 6% nuclear, that much. So every wedge represents a technology that can take a wedge out of CO2 production. And as you can see, carbon capture and storage is one of the significant ones. So let's define what is carbon capture and storage. So basically, you have a power plant, or to broaden up, any kind of industrial facilities. I should add, although the power plants are the first facilities to be confronted with the CO2 rule, there is many other industrial facilities, from cement plants to gasworks, that they do as much in emissions as the power plant does. I assume at that point it will also be their turn when EPA is done with it. But at this point, let's consider any kind of industrial facility. So what comes out of here is gases, and within these gases is CO2. So the first thing you want to do is you want to capture the CO2. Strictly speaking, what it means is I take this emission of the various mixture of the gases and I develop a chemical process whereby I take the CO2 out of those gases and let the rest of the gases to go back to the atmosphere. But I isolate or capture the CO2. So how will I do this? Well, we don't know yet. We have all these experimental technologies who do it in small scale, but we have nothing that we can for sure say will do it on a large scale. Also, what we know is these facilities are so heavy dependent on electricity, it will take 1/3 of the power of the plant will go to the capture facility. Now, who is going to build a power plant and give 1/3 of that power to clean up its emissions? Economically speaking, it doesn't make any sense. Eventually, the community with research will get there, but it's just not there yet. So, capture then means separating the CO2 from the rest of the emissions. Now, after you separate it, you have to move it out. And usually to move it out, you need to have a compressor that will compress it, so it can go to a pipeline or even to a truck. So the capture assembly includes the separation technology that occurs, that you separate the CO2 from the rest, and the compression system to get it ready to move it out. That is capture. You have another phase to this, which is transportation. If you put it on a pipeline, you take it to Texas, that's transportation. If you do it locally, you have to move it somewhere, so transportation is a factor. And then when it comes to storage, you have various options how to do that. One kind of storage is a storage where you inject the CO2 in the geology, but nothing comes up with it. That CO2 doesn't stimulate any other production of any other valuable product. Just think about this as taking the CO2, open a cupboard, putting it in the sink and locking it. That's what that is. So this particular hole here takes the CO2, goes to a deep, what is known as a saline aquifer, right? And dumps it in there. And these saline aquifers, and as I said, they are well over 1 kilometer in depth. They have the opportunity to trap the CO2. There is other formations on top who act as seals, so nothing will escape. So that CO2 will become trapped in here. Okay, that's one thing that you can do. Another thing that you can do now, you can go over here to an oil well, and I don't know if you appreciate, in oil wells or gas wells, we only recover a small portion of how much oil or gas there is, because you usually try to get out what will come out easily, but a lot of it still remains in that rock, and in order to get it out, you have to push it some way. In the old days, they used to put steam in oil wells to generate more upward movement from the oil and to come out. Right now, we have other techniques that we can do it, one of which is what? Injecting CO2 in the well. So if you inject CO2 in this well, that CO2 will push the remaining of the oil back out to be collected. So basically what CO2 does that, and I mentioned a number of times earlier, does enhanced oil recovery. So it is a standard practice, and maybe 30 to 40% of all oil that comes out of Texas is being pushed out using CO2, all right? So that's what is known as enhanced oil recovery. So CO2 has a role to play there. Now, the CO2 recirculates up and down the holes and also can be captured within the formation. Another example here, and that's what, in here, and that's what we do. One good reservoir to collect and retain CO2 are coal seams, right? Now, we are not dealing with the seams that the miners are mining, but there is an awful lot of seams which are far too thin and far too deep to be mined, right? These are called unminable coal seams. These seams still have a lot of gas, and the mining folks have been dealing with gas forever and coal bed methane. Why? For safety purposes. All the mines are degasified to get the methane out of the mine workings to try to reduce the risk of explosions. So in mining and in the mining business, we have been drilling holes and fracking holes forever in order to degasify the mine, not necessarily to put the gas into the pipeline. So what we can do here is we can go and inject CO2 in a coal bed methane well, and what we will do by doing this, we will push more methane out, and at the same time, the coal that retains the methane basically doesn't like the methane. It prefers CO2. So what the coal will do will absorb, that's not absorb with a D. It's a chemical process that provides a chemical bond. So basically the coal would like to take the CO2 and will give much more methane out. So you have two things going on for you here. You're getting rid of the CO2 because it gets absorbed by the coal, and at the same time you're enhancing more methane to get out. So what you do here, you do enhanced coal bed methane recovery. By the same token, there are ways that you can do also enhanced shale gas recovery. So the ideal thing would be then to capture the CO2, right? Use some of it at least for enhanced recovery, and the rest you can put it on a pipeline and do whatever, or you can geologically store it somewhere without any additional value-added kind of a product. That's why we talk about carbon capture and storage, or carbon capture utilization and storage. This is carbon capture and storage because nothing good is coming out. CO2 is not utilized to produce anything. This one and this one is CCUS. So that's the important difference between all that stuff. So we spending a lot of time to do research in this area, in looking as to what is the best way to inject CO2 in coal bed methane holes and also shale well holes. Try to study some of the technical issues, how much injection we can accommodate, what are the pressures, what it means to the porosities and permeabilities, all these technical issues, and at the end of the day, what are the opportunities of doing enhanced recovery. So we have already completed 2 or 3 projects that were $7 million projects, including drilling a hole in Russell County, Virginia, which is not very far. That photograph is from Russell County. It's a little bit blurred. You can see Congressman Bouch, and he always looks stiff in the picture. So he's right, Barbara. So he's out there, and you can see the console folks, Kathy, and everybody else who is right on the front line, and Phil Puckett was somewhere in there, and I can't see where he is, and Onifer. So anyway, so this is out of the Russell County experiment, which was a very valuable experiment. It taught us a number of things about injectivity, and it also, at the time we finished, was able to do some enhanced gas recovery. We do our experiments in active wells, which are producers, so we have to shut down the production, do our experiment, do a lot of monitoring. I will talk about this in a minute, and then return the well back to the owners. Now, who are the research partners here? We have ourselves, Carno Marshall Miller and Associates is a company out of Bluefield. They are doing a lot of work on site management for us, and they're all over the place. Southern States Energy Board and Jerry Hill, who's a consultant with them, the Department of Mines, Minerals and Energy in Virginia. We use the Geological Survey of Alabama because they have tremendous expertise in this topic. Sandia Technologies is a technology company out of Houston. They are geophysics people, borehole monitoring people, and so on. And we have one company which is quite unique, DNV, or Det Norske Veritas, is actually the world's largest risk management company. They're headquartered in Norway. They're basically the people who work with the oil and gas industries in risk management. And because these are large projects and there is a lot of issues and liabilities and stuff like that, DOE is requiring of us to have a risk management approach. We do a risk management registry where we identify all the risk, who's in charge of every risk, and every time we finish something, we either eliminate that because it's done, there's no risk anymore, or we'll add another one, and so on. So we have all these risk management meetings all the time. Consol Research, which is a specific group within the Consol Energy Company, is also research partners. And then in terms of industrial partners in this research is Consol Energy, with whom we have really a very close arrangement. And as you can see, Consol has been tremendously generous. We are using wells that drilled and operated by Consol. As I said, for the time we shut down the well, of course they don't operate, so they don't have any income. But at the same time, as you know quite well, the operating companies do not own the mineral. So in order to do an experiment, we also need to get the mineral owners who own the gas to agree, because for the 2 years that we'll be using the wells, they will not be collecting any royalties. And I was pleased to see a lot of our alumni are involved with the mineral owners, and they were very, very helpful. And Tom Pruitt and others, that they're local people that help us to be sure that we got all the permission from the owners to do that as well. And then we have issues with surface owners. If there is any surface owners different than these companies, we need to get them involved. Alpha Natural Resources, Dominion Energy are also big partners with us, and Flow CO2, which is a CO2 company, are currently our CO2 suppliers for the one test, and I'll get into this in a minute. So what we're trying to do, we're trying to inject 20,000 tons of CO2 in coal bed methane wells and shale gas wells. The coal bed methane wells are here in Buchanan County. The shale well is in Tennessee, in Morgan County, Tennessee. As I said, we work all that stuff with Consol. This is a 4-year project, will be a 4.5-year project. Every time we do work for DOE, we have to come up with at least 20 to 25% of cost share. So if you want to propose something to DOE that is $100, you better show your $25 in order to get the 75, otherwise you won't get it. So for us being in a university, as the projects get bigger, coming up with the cost-sharing money becomes more and more of a challenge, right? And we thank the industrial sponsors basically who came up with most of that share of cost-sharing for us. So basically the test that we will do, I'll only show here Buchanan County. This Russell County, when we did the one test, this is what we're going to do. The next test is going to be in 3 wells. The wells will shut for 1 year, that will do the injection. And then the second year, we do what we call post-injection monitoring. We've already done a pre-injection monitoring for 1 year, because there is always CO2 in the ground. that amount of CO2 changes with the seasons. So I want to know if I measure CO2 after my injection, is it my CO2 or is it the naturally created CO2? So we have 1 year of pre-injection monitoring, which is the baseline, 1 year during injection, and 1 year after injection. So it takes quite a lot of time and thousands of samples. What I wanted to show you is, you know what all these little dots here? Have you seen this before? This is coal bed methane wells, 7,000 of them. So we do know how to drill wells, we do know how to frack wells in this region. The companies do, and they do a wonderful job. The green dots are Consol's wells, the red ones I think is Equitable, and the green ones up there are Range. So below the coal horizon there is also shale gas. So there will be other holes that go all the way to the next level down to try to get shale gas. So we are here in an area which is a significant producer of what we call unconventional gas, both coal bed methane and shale gas. So I wanted you to show that so you can appreciate certain things, the fact that it is considerable geologic drilling and mining and gas extraction knowledge in here. By the way, these shaded areas that you see here is the current and past mining activities in Buchanan County, including the Buchanan mine, which is possibly one of the most modern and most sophisticated mines in the country or in the world for that matter. The other test we'll do in Tennessee is going to be on one well, and I was going to come here with another one of my colleagues, but actually our injection starts in that well tomorrow. So we will be there next week to see it, and we'll send a crew to go there this current week. So this is unique because doing tests on shale gas wells is very difficult. It's not easy companies to make those available, and we really appreciate Consol doing that. And also it's not easy to get all the logistics right. So this will be a unique test in the country and in the world actually to see some of the injectivity characteristics of shale gas. So what we learned so far out of carbon capture and storage, I believe is an important and an essential technology if you're going to do any kind of carbon management.